Fine-tuning generative AI involves adjusting a pre-trained model to better meet specific task requirements. Instead of developing a model from scratch, practitioners slightly modify a pre-existing model trained on extensive, diverse datasets. This process uses task-specific data to refine model outputs toward desired behaviors or patterns. Fine-tuning enables increased efficiency by reducing training time and computational resources. In practice, this optimization delivers significantly enhanced accuracy and relevance in generated content, making it particularly useful for domain-specific applications or organizational contexts where original pre-trained models do not fully match operational needs. Before initiating fine-tuning, certain conditions must be verified. Availability of quality task-specific datasets, ideally well-structured and labeled. Pre-deployed generative AI model on Azure AI platform that matches the target domain. Access to sufficient computational resources, GPU, or specialized processors. Ensuring an appropriate Azure environment is also crucial, including configured Azure AI Foundry, deployed Azure OpenAI service, established model monitoring, data governance, and compliance mechanisms. These preparations support a streamlined fine-tuning process, minimizing potential risk and disruption to existing services. Dataset preparation involves data sourcing, cleaning, formatting, and segmentation. These critical tasks include collection of relevant task-specific data from reliable sources, removal of irrelevant or duplicated information to maintain dataset quality, standardizing formats to match Azure AI and OpenAI model requirements, e.g., SONL format. Clearly defining input-output pairs that illustrate desired model responses. Properly prepared datasets ensure the coherence and effectiveness of the fine-tuning process, achieving optimal performance outcomes. Different scenarios require specialized fine-tuning strategies. Prompt-based fine-tuning, useful when needing nuanced control over model behavior with limited data. Full fine-tuning, adjusting all layers of the model. Ideal for large domain-specific datasets. Low-rank adaptation, LoRa targets specific groups of model weights while keeping most unchanged. Efficient in resources. Selecting the correct strategy depends on available resources, dataset size, and the specificity of desired outputs. Understanding the underlying problems and resource constraints impacts successful strategy adoption. Azure provides essential tools for an efficient fine-tuning process. Azure AI Foundry manages datasets, orchestrates training, and streamlines deployments. Azure OpenAI Service offers access to Azure-powered OpenAI models, allowing direct fine-tuning or custom model generation. Prompt Flow assists management of prompt datasets, testing, and optimization. Azure Machine Learning Studio facilitates monitoring, hyperparameter tuning, and resource scaling. Utilizing these Azure tools ensures robust and scalable fine-tuning solutions aligning with organizational goals. Fine-tuning a generative model in Azure typically follows structured stages: configuration and initialization. Choose base model and allocate computational resources. Dataset upload. Submit prepared dataset, ensuring correct formatting and compatibility. Hyperparameter setting. Configure parameters impacting speed, behavior, and accuracy. Model training. Execute fine-tuning, initiating model adjustments based on dataset. Evaluation and adjustment. Review outcomes, modify strategy and hyperparameters if necessary. Deployment. Deploy the refined model into the production environment, integrating into applications. Structured procedures ensure predictability, repeatability, and consistent results. During fine-tuning, hyperparameters significantly influence result quality. Crucial hyperparameters include learning rate, determines adjustment magnitude for model weights during fine-tuning, recommended starting small. Batch size, manages quantity of data processed simultaneously, trade-off between speed and accuracy. Epoch quantity, indicates complete passes through dataset. Too many epochs risk overfitting. Effective configuration is essential. Azure Machine Learning Studio provides automated tools, including hyperparameter tuning methods, ensuring optimal hyperparameter selection through systematic grid or Bayesian searches. To fine-tune generative models within Azure, bash az OpenAI fine-tune create / resource group resource_group / subscription ID / deployment name deployment_name / file path training_data. Sonal Azure CLI provides straightforward commands simplifying training initiation, handling datasets, and deployment integration seamlessly with Azure environments. Post-training operations enable immediate transition from development to production environments efficiently. Real-time monitoring throughout fine-tuning helps avoid suboptimal outcomes and unnecessary resource consumption, using tools such as Azure Machine Learning Monitor modules which track training statistics. Resource usage, GPU/CPU utilization. Loss metrics progression. These insights allow early identification and correction of potential inefficiencies or anomalies. Rigorous monitoring ensures effective resource utilization and high-quality fine-tuning results. Upon completion, fine-tuned model evaluation is critical. Typical assessment methods include qualitative assessment, human review of generated samples against expected responses. Quantitative assessment, employing metrics such as BLEU or Rouge scores for language generation tasks, or FID scores for generative image modeling. Azure Machine Learning recommendations offer integrated evaluation capabilities, enhancing decision-making processes and opportunities for further fine-tuning or rapid deployment decisions based on results. While fine-tuning generative models, common challenges include overfitting due to limited or excessively repetitive training data. Mitigate using early stopping, validation datasets, or regularization techniques. Insufficient GPU resources leading to longer training times or incomplete processes. Optimize batch sizes and leverage distributed training. Inefficient hyperparameter settings degrading model performance. Employ hyperparameter search facilities provided by Azure ML services. Awareness and preparedness for these pitfalls drastically improve fine-tuning outcomes and model performance. Post-deployment management of fine-tuned models requires regular performance monitoring through Azure Diagnostics tools, automated updates and model retraining setups on Azure AI Foundry, clear governance procedures for maintaining compliance and data privacy. Continuous improvement and regular updates ensure model relevance, accuracy, and performance in changing operational circumstances. Azure offers efficient pipelines and automation tools facilitating resource-effective model lifecycle management.